I don't want to keep seeing you ninjas struggle on this integral. There are a few traps here, but stick around because as we solve this one together, I'm going to show you the biggest mistake to avoid. For this integral here, notice that there really isn't a good shortcut, and sometimes students get frustrated because they're looking for a quick out. But really, unfortunately here, all we can really do is let u equal the whole natural log of 1 plus x squared expression. Now, when we take the derivative, remember for a natural log, it's 1 over something, where the something happens to be what's inside the parentheses, this 1 plus x squared. And then using the chain rule, we got to multiply this by the derivative of the inside, giving us this 2x dx. And then, of course, when you combine this on the numerator, you just get 2x over 1 plus x squared dx. Okay, now what's left over? Well, if we took the whole expression for our u substitution, now when we're working with dv, it's just going to be this remaining part dx. Now, for dv equals dx, when you integrate both sides, you will get v equals x. And now we can go ahead and move on to where you're probably getting stuck, which is going to be this integration by parts method. And if you remember, the integration by parts method says we take uv minus the integral of v du. So multiplying u and v together, you get this x natural log of 1 plus x squared. And then when you subtract this integral, we are multiplying together the x, and then this expression 2x over 1 plus x squared, all dx. And now if I want to simplify things further, what I can do is for the integral part here, I'm going to combine the x times x, giving me x squared, and then I'm going to bring out the 2, which you're going to see later why I'm doing that, because ultimately now, by bringing out the 2, what I can do now is for the inside of this integral, I have x squared over 1 plus x squared. And this is the area where you make the biggest mistakes so often, and it can be very frustrating because maybe you gave up at this point. A lot of times students will maybe go in circles with integration by parts, which happens. And then when they get to this step here, they think they're going into circles again. And so they waste time and try a different method. Because when you look at this, notice that you may have tried a partial fractions decomposition and it didn't work. Because not only is the numerator's power here not smaller than the denominator, but if you try and factorize the denominator, what are you going to get, right? So this is another tool you need to remember, which is going to be polynomial long division. So if you remember how to do this, and I've covered it in another video, ultimately we have this idea of a quotient, which we're going to find, and then we've got the dividend and the divisor. Now for the dividend, it usually helps to put in the missing terms of the polynomial with zeros in front. So because we have x squared for the dividend, I'm going to put this plus 0x plus 0 there to kind of fill in the space. And then ultimately what I'm doing here now is I'm asking myself for the left, this divisor, how many times does x squared plus 1 go into the right part, the dividend? And all you got to really look at is, for the first step here, look at the largest powered terms, and that's why I wrote 1 plus x squared in reverse order on the left, so that the leftmost side has the highest degree of x. Well, x squared goes into x squared one time, right? So, okay, the first part of our quotient is going to be a 1, which I've marked here in a different color. And then when we multiply 1 through for the divisor for every term, we're going to write that down below here and subtract it from the dividend. And I'm also going to put in a missing term for clarity, this 0x, because on the left-hand side, we didn't really see it, but it just helps to line all the terms up. And this will give us a difference of 0 plus 0x minus 1. Now, like in my other video, sometimes you got to keep repeating this, but because we're left with minus 1 here, there is not going to be any other steps of having to bring things down further. This is going to be our resulting remainder. And so the final way of reducing that fraction turns out being the part of the quotient we had this 1 minus the remainder, which is going to be this minus 1 all over the original thing we were dividing by, right? And so what this means is if we bring down the integral we were working with above, the part on the right, that x squared all over 1 plus x squared, we were able to just decompose it, and we can now substitute it with something that's easier to work with, which is going to be this 1 minus 1 over x squared plus 1 part. And now all we can do is we can just distribute this minus 2, and to break the right side up into separate integrals that are easier to work with, giving us this final expression here. And notice that for this part here, this first simpler integral, minus 2 times the integral of 1 dx, it's just going to be a constant integral problem to solve, right? Minus the integral of 2 dx will just simply be 2x when you subtract that. And then I purposely left the 2 out in front of the right-hand side because if I just have the integral of 1 over x squared plus 1 dx, that's a very famous integral you should know by heart, which is going to be your arctangent of x. And that's not what I'm going to uncover in this video, but for the next problem,